Hello everyone, how are you all? I hope you all are well. So welcome back to the next topic. Today we are going to discuss about the next topic. We are moving further from the stoichiometry. So if you haven't seen that video, you can just click on the I button and you can just check that video and you can go through the stoichiometry and also about the mole concept. Now we are going to discuss further about the next topic from the stoichiometry, that is the empirical formula. After finishing this empirical formula, we are going to make a separate video for the problems which are related to the mole concept, stoichiometry and empirical formula together. Okay, so first we are going to finish empirical formula. So let's see what is this empirical formula all about. Now if suppose I will give you a fraction, suppose I have given you a fraction 4 divided by 12, okay, and I will ask you to simplify it, then what you will do, you will cancel the ratio and the answer will be coming like 1 by 3. Okay, same if I will be giving you one more fraction like suppose 2 by 8, then again you can simplify it and you can write the answer as 1 by 4. Okay, but if I will give you one more fraction like 1 by 3, you cannot further simplify it, okay, because already it is a simplified form and the value will be coming 1 by 3 only. Same is in the case of empirical formula. If suppose I will give you one molecular formula of a compound C6H14, okay, there are 6 carbon atom in this compound and 14 hydrogen atom. This compound is known as hexane. Okay, now if I will ask you to simplify here like we did here, what you will do, you will simplify it and the value will be coming like C3H7, okay, because you have taken 2 as common here. So this formula turning into the simplified form here, this is the simplified form of hexane. So this simplified form of hexane here, that is C3H7, is known as empirical formula. Okay, so what we concluded? We concluded that the simplified form of any molecular formula is known as empirical formula. Okay, we can see further examples like suppose we have one compound like C2H6, okay, this is known as ethane. If I will simplify this, it becomes CH3, okay. So again this is the empirical formula of ethane. So it means the simplified form of molecular formula is known as empirical formula. One more example we can see, like suppose we have C6H12O6, that is a very common substance, we all know. This is known as glucose, okay, and if you simplified it, it becomes CH2O. CH2O, okay, because we have taken 6 as common. So this is the simplified form, okay. So this is the simplified form of the glucose and hence we can say this is the empirical formula of glucose, okay. Now we can take one more example. Suppose we have NH3, which is ammonia gas, that is NH3. If you try to simplify this, you cannot further simplify it. So on simplification also it will remain NH3, okay, or else we can say that it cannot be simplified. So in this case the empirical formula and molecular formula is same, okay, that is equivalent to each other. So what we can conclude, that empirical formula is a simplified form of molecular formula. Now we are going to see that how it is related to the molecular formula, and how can we calculate empirical formula, and how can we calculate molecular formula using the empirical formula. So you understand that a simplified form of any molecular formula is known as empirical formula. Okay, now let's discuss that how the empirical formula is related to the molecular formula, and how can we use empirical formula to calculate the molecular formula. Now we are going to see that how we can calculate empirical formula, then we are going to see that the relationship between the molecular formula and empirical formula. Now suppose you are provided with a question that there is a compound where carbon, hydrogen and oxygen is there. I am writing the symbols over here. A compound is there, okay, which contain carbon, hydrogen and oxygen. Okay, this is just an example, and they are provided with their percentage. The percentage of the carbon, hydrogen and oxygen in a compound is given. Suppose carbon is given around 60%, hydrogen is given around 8% and oxygen is given around 32%. Because we are taking it as an example, so we can write any percentage here. So there is a compound where carbon, hydrogen and oxygen is there, and their percentage are given to you. Now they will ask you that to find the empirical formula of the compound. Now what you are going to do, first of all you have to write their atomic masses, that is the atomic masses of the element. Like carbon 12, hydrogen 1, oxygen 16. Now after that what you have to do, you have to take the ratio of atomic mass with, you have to take the ratio of the percentage of the substance with their atomic mass. Okay, so likewise carbon is 60%, so it should be divided by 12. Hydrogen is 8, so it should be divided by 1. Oxygen is 32, so it should be divided by 16. Okay, now you need to divide all the values, so it will come like 5, it will be coming 8 and it will be coming 2. Okay, now after finding all this value, you have to simplify these value, or you have to find the simplest ratio over here. Okay, so how to find the simplest ratio? Whatever your values are coming after taking the ratio of percentage to the atomic mass, that is 5, 8 and 2, you have to use the lowest value out of 3 or 2, whatever the number of elements are there. In this case there are 3 elements. So out of these 3 values, I have to choose the smallest one, which is 2 here. Then this value again I am going to use to divide all. Okay, again I am going to use to divide all. So I will be dividing 5 by 2, 8 by 2 and 2 by 2. Okay, so it will be coming 2.5, it will be coming 4 and it will be coming 1. Okay, although these are the percentage taken by me only, so the ratio or the values are coming like this, but sometime what happen, the values will, all the values will be coming in the decimal form. So when all the values will be coming in the decimal form, what you should do here only, you have to round off them to the nearest 0. Okay, you have to apply the rule of the rounding off, and you have to round off the values to the nearest 0. But there is a problem. If the value is coming exactly 0.5 something, like 2.5, exactly 0.5, then what you have to do, you have to divide all the values with 2 to make it in a simplest whole number ratio. Okay, so as it is 2.5, it is 4, it is 1, so again we need to multiply all the values by 2. Okay, when you do so, it will be coming 5, 8 and 2 again. So as C is coming 5, so we will write C as 5. Hydrogen is coming 8, so we'll write hydrogen as 8, and oxygen as 2, so we write oxygen as 2. Okay, so this is known as the empirical formula of compound. That is how we calculate empirical formula of compound. Okay, first you write percentage, then you use atomic masses, take the ratio of the percentage with the atomic masses, then simplified the ratio. Okay, if the value is coming in the decimals, then you have to round off to the nearest 0. If it is exactly 0.5 like in this case, we have to multiply all the values with 2 again to make it the simplest whole number, and whatever the value is coming in front of that element, you have to use it as its number of atom to write the empirical formula. That is how we calculate the empirical formula of the compound. Now we are going to see one more example. So students, now we are going to see another type of the questions which is based on the empirical formula, and how we can find the empirical formula. We are going to see that. Like, a compound was analyzed and found to contain 13.5 gram of calcium. So instead of percentage, here they are going to give you the mass of the substance. Like, a compound was analyzed and found to contain 13.5 gram of calcium. So amount of calcium is 13.5 gram. Then 10.8 gram of oxygen. Oxygen is 10.8 gram, and 0.675 gram of hydrogen. Now they are asking to find the empirical formula. Now what you have to do in such cases, if you are provided with the mass of the substance, then you can convert them into the number of moles first. So what you are going to do, you will find the number of moles for every element here, like number of moles of calcium first. Okay, so number of moles, as you know, the formula is given mass divided by the molecular mass. Now given mass of the calcium in this case is given 13.5, and the molar mass of the calcium is 40. So when you take the ratio, it will be coming around 0.337. Okay, so that is the number of moles of calcium. Then you have to find the number of moles of the next element, that is oxygen. So when you find the number of moles of oxygen, again the formula is given mass upon molecular mass. That is this time 10.8 divided by 16. We know the molar mass of the oxygen 16. So it will be coming around 0.675. Now we are going to calculate the number of moles of the third element, which is hydrogen, and its formula is again given mass upon molar mass. Now hydrogen amount is 0.675 and will be divided by 1. Approximate we used to take like that. So it will be 0.675 again. Now when you find all the number of moles, okay, we have converted the masses, the given masses, into the number of moles. Then you have to again do the same thing which you did in the previous question. That is, you need to identify the smallest mole and divide all the values again. Like in this case, if you see, the smallest mole is a mole of calcium. So you are going to divide all the moles which you have find with the smallest value, which is 0.337. So in case of the calcium, it is coming 1. In case of 0.675 divided by 0.337, it may be coming 1.9 something. So we have to round off the value here. We are going to take the simplest whole number value. So it is going to coming equivalent to the 2. Okay. Then we are going to use another value, that is 0.675 divided by 0.337 equivalent to 2. Okay. When you use this value, now you have all the simplified value with you. Like calcium is coming 1, oxygen is coming 2, and hydrogen is coming 2. So you can write here as CaO2H2, okay, or else we can also write it as CaOH whole twice, okay, which you know is also known as calcium hydroxide. Okay, it is known as calcium hydroxide. So that is one of the way by which you can calculate the empirical formula. So this is another type of the question where the masses of the substance are going to be given and you can calculate the empirical formula of the substance. Now we are going to see the relationship between the empirical formula and molecular formula. Student, now we are going to discuss about the relationship between the empirical formula and molecular formula, because actually what happens, sometimes the numerical used to come and they may ask you about the to find the empirical formula of the compound as well as the molecular formula of the compound. So how it is related? So basically, if you have to find the molecular formula of the compound using the empirical formula, so there is a relationship, that is molecular formula will be equivalent to empirical formula whole n. Okay, that is molecular formula is equivalent to the empirical formula of the compound and multiplied by whole n, that is small n. Now what is this small n? This small n is a ratio, okay, and it is a ratio of the molar mass of the substance whose empirical formula we are finding with the empirical formula mass. Okay, if the molar mass of the substance will be divided by the empirical formula mass, then we can find the value of n, and then using this n you can put the value here, you can find the molecular formula of the compound. Now sometime this molar mass may not be provided directly, sometime it is provided directly and sometime they may not give you. So sometime in place of the molar mass they used to give you V dot D. Basically it is vapor density. Okay, now what is the meaning of this vapor density? Vapor density means it is a density of any substance with comparison to the density of the hydrogen atom, okay, or the hydrogen gas. So density of any substance when compared with the density of hydrogen substance, that is known as vapor density. And we don't have to calculate the value of vapor density, it will be provided to you when you are going to calculate the value of molar mass. Okay, so basically vapor density is related to molar mass like this, that if molar mass you have to find by using vapor density, it will be vapor density multiplied by 2. This is the formula we are going to use to find the molar mass using vapor density. Because suppose a question is there and they will give you everything and then in the last they are providing you vapor density instead of molar mass. So in order to find the n you need molar mass. So for finding the molar mass you can take the twice of vapor density, you can put that value here. Empirical formula you may have already calculated that time. So whatever the mass of the empirical formula is there, you will be taking it here and then you can calculate the value of n. Now one example I am giving it to you. Suppose if the empirical formula mass is suppose 100 gram, okay, just an example, and the molar mass of the substance is given to you around suppose 202 gram. Okay, so what you are going to do, you will find the value of n by taking the ratio of the molar mass to the empirical formula mass, that is 202 divided by 100. It is coming 2.02, but again I am saying it is required to be round off. So we are going to round off it to the nearest 0, so it will be coming 2.00, that is 2. Okay, now the molecular formula of the substance, whatever the empirical formula of the substance you have already calculated, E dot F means empirical formula, multiplied with 2. Okay, so when you multiply it with 2, then you can easily find the molecular formula. Okay, so like that you can calculate. Suppose if the empirical formula is CaCO3, okay, then you will multiply it with 2. So what it becomes? It becomes Ca2C2O6. So that is how you can calculate the molecular formula. So you can see molecular formula is equivalent to empirical formula whole n equivalent to molar mass upon empirical formula mass. If molar mass is provided, okay. If it is not provided, then vapor density may be provided. You can take that twice, calculate it. Just an example, like empirical formula mass is this much, molar mass is this much. You can take the ratio and find the answer. Now this is just an example, or just I have shown you that how you can do it. But the actual numerical problem we are going to solve in the next video. In the next video, we are basically going to solve all the problems related to the mole concept, related to the stoichiometry, and related to the empirical formula and molecular formula. Okay, so goodbye for now. So like my channel, subscribe it and share it to maximum. See you in the next video.